everyone. Ajay Senthil and Dr. Mann and all the students and coordinators who are here. So this paper is all about selection of appropriate and right industrial network protocol for all the smart factories. To start with, let's start with an analogy. Recently we had Diwali, right? And everyone went to their hometown. How did we select it? Mode of transport, right? So to start with, my daughter said she had a dream that she want to go with the ship. But the problem is the area where I say there is no ocean, which is Solapur. So there are various mode of transport, right? Whenever we want to ship something or we want to travel by ourselves, how do we select the specific transport mode, right? So for that, there are various consideration we take. One which is speed, another which is cost, then location where we want to go, and definitely security. Based on that, we select the appropriate and logical transport mode. Now, why we are talking about this and how does this correlate with the smart factory? So, right selection of transport mode is exactly the right analogy for the right selection of the industrial network protocol. So, how it is so? In the industrial context, let's take an example. We have a PLC, an industrial robot, and whenever these two individual devices speaks with each other, communicates with each other, that's what we call as a communication protocol. So hereafter, from this point, please use this analogy that communication protocol is equivalent to the mode of transport as an analogy point of view. So what is the complexity? Why in the first place this is a topic of research? So one of the reasons is the sheer complexity of the shop floor and especially the smart factory, because we are involving the various kind of third-party devices in the existing manufacturing environment. For example, we have industrial cameras, we have third-party scanner that we introduced for the traceability. Then we attach industrial printers, then we use servo motors, VFD drives, and we are adding these many devices day after day, months after month into the same factory, and we want to call it as a smart factory or the modern factory. Now, while we are doing this, we are not thinking, or there is no documented framework to choose the mode of transport, that how exactly we want to communicate the data. So that's what I call it as a spaghetti of the network protocol. Now, if you see on the left side and right side, these are the various third-party devices, or in the middle, these are the different industrial network protocols, right from DeviceNet, MQTT, OPC-UA, IO-Link, Modbus, and whatnot. And in fact, these different various industrial protocols have evolved from last almost 5 to 6 decades, my friends. So why the protocol selection still matters? So first of all, interoperability. Whenever we are introducing a new device on the shop floor, as a smart factory consultant, we need to ensure the long-term connectivity and adaptability of that device to the upper layer of the IT system, the real time. Whichever new device, it could be a camera, it could be RFID, a new motor, or a new sensor, it has to have a real-time connectivity, a vendor dependency, and then the integration with the legacy system. In the factories, in fact, there are some factories in the world that are running literally from the Second World War, and those machines are still absolutely running fine, and the production managers, leaders do not want to scrap that machine. We still want to use that. At the same time, we want to bring that machine into the mainstream in our smart factory by collecting the data. Now, the challenge that we have is the IT-OT convergence. Now, this is a very interesting chart, judges and all the team members, students and coordinators. Why the problem exists in the first place? It all starts with the 1950, right, where the IT and OT was quite separated. In the 1950, the introduction of mainframe computers took place, and then in the OT, it were the analog systems. By the time we entered in 1960 and 1970s, in 1960s, disk storage drive was introduced. In 1960, world's first industrial robot was introduced into the General Motors, United States. By the time we entered in 1970, still IT and OT was absolutely separate. We had microprocessor, and then we had world's first PLC launched by Schneider Modicon in 1970, and then we had personal computer by 1980. It was in fact by around even up to 1990, the IT and OT was absolutely isolated and different. And that's the reason this problem exists. We call it, or we call every time why there is an IT OT convergence requirement. But the question is why the divergence exists in the first place. So this is the answer why the IT OT divergence exists in the first place. And now we are, we talk about next two decades, 2010 and 2020. That's the first time, this IIoT and IT/OT integration gained the momentum. So, to summarize, we have one plant and many protocols. So that's the typical factory automation pyramid from L0 to L4. L0 is all the sensors, switches. L1 is PLC, CNC robots. L2 is HMI, SCADA, MES, and then ERP. And if you see, for every layer, we have kept adding the different layer of communication protocol. For sensors, we use IO-Link, Modbus. For L1, L2, we have Ethernet IP, OPC. Then for ERP, MES, we use MQTT, REST API. But these all decisions were made based on the past experience or based on what vendor is offering. There has been no standard document or there is no standard framework available even at the time of this research that was made. So the gap is in current practices. Most of the guidance is either vendor specific. For example, Profinet. Siemens would popularize Profinet. That why don't use Profinet? Rockwell will popularize Ethernet IP. Why don't use Ethernet IP? OPC UA. There is a European body. They will popularize OPC UA. So everyone is pushing their own protocol, and that's what we call as a vendor-centric. Lack of transparent and reproducible scoring method, and that's what the topic is. How we can formalize a framework to solve this challenge. So to summarize, the core objective why this research was made, because of the two primary reasons. One is assess the technical performance and then understand the practical deployment concern. Provide a reproducible decision making framework. That's what we are going to see in next 5 slides. Then balancing the technical performance and practical deployment, and then framework which can be used for greenfield and brownfield. Because whenever we introduce a framework, it has to take care of all the factories, the old one and the upcoming ones. So the framework, here we are now moving from confusion to clarity. So far we have talked about the divergence of protocol. So there are 6 decision factors that we are considering. Quantitative scoring, objective comparison. We will compare all the available industrial protocols based on the various qualitative and quantitative factors. We will evaluate its impact on the multiple environments. The decision traceability, bridging the gap, and the framework has to be reproducible. So these were the 6 key criteria that were kept in mind while writing this research paper. So what are those 6 dimensions? The first and foremost is real-time capability. Any protocol that we introduce in the factory, that has to have a real-time capability. The next is interoperability. The new protocol that we're trying to introduce, the new device that we're trying to bring, has to have the interoperability between horizontal and vertical layer. The security, very critical. The legacy support, it has to communicate with our machines which is in the shop floor from the Second World War. IoT readiness, and then last but not least the bandwidth and throughput support. So we are bringing some mathematics over here, and we have a weighing and scoring method. Now you will see this table, but let me simplify this for you. So these are all the popular protocols, and these are the 6 criteria that we just saw in the last slide. So Profinet, real time, the score is 9 on a scale of 1 to 10. Bandwidth 8, interoperability 6, security 6. So that's the number we have given. Now you may wonder from where this number came. So for this number, we have gone through all the research paper of the protocol of who has authorized those particular protocols, and based on that we have reached to these numbers. And as I said, right now, in fact, at the timing of writing this paper, there is no readily available framework in the market. So weighing and scoring method point of view, so we will take a use case, for example, real time, bandwidth, interoperability, security, and IoT readiness. At the time of bringing any new device in the shop floor, we will go through these different numbers and we will assign the percentage that, okay, what is my priority? For example, a sensor, sometimes you may need a real-time data and sometimes you may not need. For example, a temperature sensor, you really want the microsecond level latency, or if it's a safety device, it would definitely lead the microsecond level latency. So temperature feedback, we can get even 1 second frequency, but definitely not the safety signal. So based on that, we will score this in the weighing scoring example. So this is the table that we talked about, right? And these are the number, and this is the arithmetic. So we have, in the last slide you saw, we have given the percentage, 20%, 15%, 15% for those 6 criteria. And as an example, we have taken the Profinet and we have scored that what is the total score coming for the respective protocol. Higher the score, the more appropriate that protocol is for our smart factory. One of the example of the retrofit, which is legacy, which is brownfield. Again, we have, let's example, we have a machine which is developed and built in 1990 of Profibus system. So we need a legacy system support. We want minimal disruption. We have cost sensitivity. We don't have budget to spend on this. So what the protocol should be selected. We want structured data access. We want security as well. So how should we select? How should we apply this framework now? Now all the research has been done. Now how to use it practically? So for this particular brownfield, imagine now all the smart factory consultants sat together in a room and they decided, okay, real time 10%, bandwidth 10%, interoperability 15%, and after this and legacy support, which is most important, 35%. So after computation and applying the framework for all the protocols, so this is the score that's coming. So again, if you want to know how these numbers are coming, for example, IO-Link, why 6? Because from this. Again, for protocol Profinet, why 9 for real time? So it is coming from this slide. So after this, then the protocol ranking came, and now we have complete clarity that which protocol is scoring higher. So it's OPC UA for this particular legacy case, and that's the computation for rest of the protocol. So the interpretation is of this particular use case that OPC ranked higher because it was a brownfield case, and then Profinet and IO-Link are also strong, but again at the same time, those protocol has a specific purpose. For example, a Profinet would be more appropriate for the different set of devices than handling the legacy system, which is for this particular brownfield factory. So applying this protocol selection framework for brownfield and greenfield helps us to derive the context-driven decision. So now, because of this framework, we don't need to take decision in the isolation. We can take the decision back with the data, back with the research. Again, protocol effectiveness depends on the application and system need. For example, in the shop floor, if I want to introduce a sensor, there are 10 different protocols, Ajay, Senthil and ma'am, right? There are 10 different protocols. It can be MQTT, it can be IO-Link, it can be OPC, but how do we select? What is the priority? If I want a micro 7 level data, then definitely the need would be different. So we will rate higher to the real time. So this is the structured framework which has not been available so far, and that's the innovation piece that I want to bring it here, that no specific particular framework has been available so far at the time of this. So these are some of the reference, questions. Thank you so much.
Thank you, Prasad.
Yeah.
So Prasad, one question. Okay, so this framework is there where you can choose for a brownfield or a
Correct.
greenfield. But even if it is a brownfield,
Correct.
okay, and most of the scenarios it is brownfield, but it's not completely the legacy.
Right.
Okay, there is a combination of legacy, there is a combination of smart, there is legacy of advanced
Correct.
machines also.
Correct.
Okay, so how do you like by applying this framework, how do you don't go choosing multiple things, okay, which creates infrastructure burden
Correct.
for that plan, okay,
Correct.
and instead of like choosing the right protocol for a particular use.
Correct, correct, correct. So for example, Ajay, if there is a factory, right, and we have, let's say, we want to introduce 10 different devices, right, the factory is already running, it's a typical brownfield case. And now, we talked about that factory automation pyramid, right? So if we want to introduce a particular device at the bottom of layer, which is sensor layer, the first thing of those 6 selection criteria is like real time. Do we need real time data? So if we do not need real time data, we don't necessarily need IO link, or we don't necessarily need to invest in OPCUA. The MQTT also would work over there, right? So that's one of the decision making framework. The second is, if there is a particular case, let's say safety, if the safety device has been interrupted, the signal has to go to the upper layer, which is PLC or SCADA layer. It has to be in the fraction of microsecond. So that time it would be the particular case of, for example, IO-Link. That's one of the most popular and or Profinet for that matter. So considering the brownfield environment, and because we add this smart connected factory project, or we introduce, for example, predictive maintenance, new sensor, at that time, most of the time what we have observed that engineers or the smart factory consultant tend to take the decision what vendor is offering to them, rather than having this decision backed by the data. So actually it depends on case to case that which devices we are adding, but I fully agree with you. The decision has to be taken in considering with the current infrastructure setup. So yeah, I agree with you, the current infrastructure setup. For example, if OPC is already available, for example, Ignition SCADA, right? Ignition has an inbuilt OPC UI. So in fact, we wouldn't even need Kepware because we already have purchased one license, right? So that time the cost sensitivity will come into picture. So that's the part of framework. So yeah, right, Ajay, thank you.
I could see a lot of references on international SAE you have
Yes,
picked
yes.
up. Can you go back to those slides?
Yes.
What is the reference or influences which you took from there?
Yes. So I will mention some of the references. So now these references talks about something in isolation about the particular protocol. So for example, let's take an example of Deloitte. So it was about smart manufacturing and operations survey. So that particular, almost 100 pages report talked more about what are the shop floor challenges. And one of the key takeaway was the same, IT/OT integration, that manufacturers are struggling with keeping up with the old machine and bringing new machine, and how do we integrate. So that's one example. Again, this particular paper, for example, it talked about the analysis of OPC UA. So these were in isolation. Even after a lot of study, I did not found a single paper which has everything together and which is helping our new generation and new smart factory consultant to take the decision. Yes, so this is the framework, and now I will take the decision. So
This is a very good framework to start with. I think you have consolidated these things and came up with a scoring methodology for a brownfield and a greenfield. As Ajay said,
yes,
the need of business is more important, and what is the system
Correct.
is more important. The second part of the system is every manufacturer has their own procedure to say that
True
this is
that.
the system which I wanted to provide based upon their availability and the source of environment which they have.
right,
Now, every manufacturer has their pros and cons. For
Correct.
example, a servo drive for a paint robo, Kuka might be the best.
correct,
For a manufacturing or assembly purpose, Fanuc might be the best.
Correct.
I'm just giving an example, I'm not
Right.
quoting any manufacturer
Yeah,
here.
yeah.
So, where the application specificness and the maintainability of the system is more important for us. If I
Correct.
put this framework together,
Mm-hmm.
so will I lose the competitive advantage and maintainability of the machine moving forward? Because I cannot change a manufacturer to say that change this from A to B.
Right, right.
Because
right.
I don't have that autonomy to say that,
Autonomy.
because I might be a spy of
Correct,
the
correct.
entire junk which he is
Right, right, right.
manufacturing.
Right,
How
right.
we are going to emphasize this system across and
Right.
how it can be taken forward across the
Absolutely.
globe, I would say, not
Absolutely,
enterprise.
absolutely. No, you rightly pointed out this, Senthil. In fact, there is a famous saying in English, you might have heard, like, penny wise, pound foolish. Just to save some bucks, we cannot lose, everything. So absolutely right, Senthil. So, let's say you want to buy 100 KUKA robots for a paint shop, right? Or any particular robot, right? That time, if the particular vendor is offering a huge discount, so we have, very less choice to make and apply this framework. Where this framework could be effectively applied is whenever we work in isolation, right? For example, we are adding some sensors on the shop floor with the existing infrastructure, right? And we have now two choices, whether to use MQTT or whether to use real time, like IoT or Profinet. So there we can use this framework. But again, whenever there is a cost related thing, again, this, ABB or KUKA, they would definitely come up with the modern protocol, let's say, because if we try to buy now, right, or in the last 5 years, because that awareness has been increased. Now imagine that if we are tomorrow building a new factory, new smart factory, right, and there is nothing, it's all ground zero. that time this framework would be very important, so we can make the decision backed by the data. And we can influence manufacturer also, that from my automation pyramid from level 0 to level 1, I want to ensure consistency. I want to help and optimize my maintenance team's productivity, so that every time knowledge retention should not be a burden for the maintenance manager or the production team. So whenever we enter essentially into a design of new smart factory, I would say definitely this framework would be helpful. But as you rightly said, if an existing factory, if you want to use the same vendor and leverage the cost benefit, there would be some limitation. I agree with you.
One suggestion I have, Prasad. So today probably your framework has a manual step involved
Right.
in defining the weightage.
Right.
Maybe if you can have a selection, okay, your cycle time
Correct.
is this,
Right.
okay. These are type of a parameters you are
Correct.
trying to collect. This is your use case, intended use case
Mhm.
for which
Right.
you want to connect. I don't know, maybe something selection, and
Selection.
based on that, it automatically gives. Okay, this is probably
Probability. Yeah.
the weightage
Absolutely
you
right.
should give for
Right.
real-time data connectivity or
Correct.
whatever.
Based on various factors,
Yes.
right? And I think that's a great suggestion. In fact, a dashboard, where the smart factory consultant can feed his input, and the software provides some suggestion, and then he can consult with his, team and take that
Validate.
right and validate it. Absolutely. Yes. Yes, ma'am.
I just wanted to know how do you plan to implement this framework in existing factories? You're part of John Deere, so
Yes.
would you be able to explain some use cases or
Yes,
the
yes.
examples where
Yes,
you
yes,
plan to
absolutely. Yes, yes.
implement?
So, in fact, we are working with, Gautam Mohapatra and Satyam's team for one of the use case where we aim to measure the oven temperature and understand the pattern of, how much oven is consuming the temperature. Is there any temperature leak? Is there any, current leak? And what is the overall pattern against the production? So for that particular, we had a use case of which sensor to use. Now again, when you Google and reach out to 4 vendor, every vendor would say, because sensor will does the same job, ma'am, right? All 4 sensor will does the same job, but it's about how it is transmitting the data. So that time we decided here now real time is one of the most important thing, because if the sensor data is delayed, then it will cost us, because for example the data frequency has to be at least 10 seconds. After every 10 seconds data has to be updated. So MQTT will not work, because MQTT is particularly required into the remote area. So here we need modern protocol like IO-Link. So that's where we use this framework, and we are going forward with that project. The same thing I'm aiming to apply with within all the next project, and this particular research that has came from my own experience, because I started my career from maintenance, and I used to say, okay, this is the sensor, this is the protocol, connect and start connect and start the show. But now when I look back, right, in the hindsight, and I question myself that how did I selected that sensor? Did just because someone told me, or was there any research involved? And when I realized there was no research involved, and that motivated me to come with
I
this.
think this is a very good inputs that we can put into our capital equipment acquisition process scoping, which will help us to substantially improve the consistency across the data flow, which is a
Right.
good thought. But streamlining this with the manufacturer would be a biggest challenge, and this is something where we need to have some
Right.
more researchers on how to take it forward.
Right, right.
As a whole would make a sense.
Right, right.
Thank
Yes,
you, sir.
thank you.
Hope your daughter will travel on the ship.
Yeah, absolutely. Thank you so
Maybe
much.
during rainy season you can try.
Yeah.
Maybe not a ship, but maybe a boat.
Yeah, absolutely. Thank you so much. Thank you, Ajay. Thank you.